Okay, we just finished part one. We're going to go on to part two. Let me dismiss my image, and we're going to talk about buoyancy, buoyancy in a liquid. Buoyancy is the apparent loss of weight of a submerged object. The amount equals the weight of water displaced. Now, the buoyant force is the amount of the weight of the water displaced, irrespective of the weight of the object. It's the weight of the water displaced. That's the buoyant force. Okay, the displacement rule. A completely submerged object always displaces a volume of liquid equal to its own volume. You place a stone in a container that is brimful of water, and the amount of water that overflow equals the volume of the stone. And in 24, 25, one of the things that we would take an irregularly shaped object that's hard to measure, let's say like a bolt or something like that, when we were doing density. And one of the things we would do is we would drop it into a cylinder of water, and you could see the rise in the cylinder was the volume of the odd-shaped object. So the amount of water that's displaced is the volume of the object that you're measuring. Okay, a cook who measures a specific amount of butter by placing it in a measuring cup with water, with a measuring cup with water in it, is using the principle of buoyancy, the displacement rule, the concept of density, or all of the above. Well, he's using the concept of B, the displacement rule. He's using the displacement rule. He wants to see how much the butter displaces when he puts it in the cup. Okay, now the buoyant force, the net upward force that a fluid exerts on an immersed object is equal to the weight of water displaced. The difference in the upward and downward forces acting on the submerged object is the same at any depth. And they're showing you some little vectors here. At this level, there's the force downward is one of these vectors. The force upward, because there's a distance here, it's 2. So the difference is 1. Well, look at it here. There's 3 pointing down here. There's 4 pointing up here. So what's the difference? 1. And here they show 5. I lost my cursor. Here they show 5, and here they show 6. You can see that the vectors increase with increasing depth, but the difference between the downward vectors and the upward vectors is always 1 in favor of the upward vectors. That's the buoyant force. So it's irrespective of depth. Now, the deeper you go, the more pressure you'll experience, but the difference, the delta between the top and the bottom surfaces is always going to be the same. In this case, one unit, whatever that vector force is. Okay. How many forces act on a submerged body at rest in a fluid? 1, the buoyancy. 2, buoyancy and the force due to gravity. None. In accordance with the equilibrium rule, force is equal to the net force is equal to 0, or none of the above. Well, it didn't ask anything about the net force, so we can dismiss C. And there are 2 forces. There is the force due to gravity, and there is the buoyant force. So it's B. There you go, 2, buoyancy and the force due to gravity. You don't lose gravity once you put something in a fluid. Okay, as a matter of fact, I mean, I think I've mentioned in the past, I tend to make, I like to make sourdough bread, and I throw things on a scale and I measure everything in grams. I don't use cups or ounces or anything. I measure it in grams, and I just keep pouring the objects in my bowl, and I just measure it in grams. And because there is still the force of gravity on things, even though I'm pouring into liquid, there's still the force of gravity. Okay. We're continuing buoyancy in a liquid. Sink or float. An object sinks when the weight of the submerged object is greater than the buoyant force. So the buoyant, the object is going to have a size, irrespective of its weight. It's going to have a size, and that's going to be the buoyant force. So when that weight is greater than the buoyant force, then it's going to sink. It's neither going to sink nor float when the weight of a submerged object is equal to the buoyant force. The object will remain at any depth. Back when I worked at Southwest Research, there was a paper that came out that about these fellows that were mapping out the aquifer, which is a cave filled with water, and so they had a little submersible object that was neutrally buoyant. In other words, it would neither float, it would neither rise nor sink, so that it could map out the water in the cave. Now, float when the weight of submerged object is less. It'll float when the weight of the submerged object is less than the buoyant force it would have when fully submerged. When floating, the buoyant force is equal to the weight of the floating object. When floating, the buoyant force is equal to the weight of the floating object. Okay, and that's the end of part 2 on buoyancy.